Well, it turns out that high voltage wire is kind of hard to come by. I looked at all the usual vendors, Mauser, DigiKey, Allied Electronics, and so on. Surplus vendors like Surplus Sales in Nebraska, eBay, Amazon, you name it. Your standard hookup wire, like you see all the spools of in the background, 600 volt. That's your standard PVC wire, and you can get stranded, solid, and pretty much any gauge. You get above that, it gets kind of tricky. If you want to get up to 20 or 40,000 volt, like the anode lead, that's not too hard to find, but it's expensive. But if you want something rated for like 2, 3, 5,000 volts, then it gets trickier. I did see there is some commonly available, it's said for the RC market. I assume that means radio controlled. But it was typically either large gauge or small gauge. By that I mean I was able to find 2 and 3,000 volt wire, both surplus and new, like 10 gauge, 12 gauge, really thick stuff like house wiring. I don't want that. Or it was too thin, like 26 or 28 gauge. Or it was solid, whereas I want stranded. So one common source for component lead, I mean the most common thing I found was this stuff for test leads. But typically this has one very fine conductor in it that's very flexible. It's not stranded. It's not what I want for this. I want something that's got a little more beef to it because there's going to be some current flowing through this wire. The one source I did find coming up again and again on Amazon was from China. I think it was 3,000 volt wire in any gauge, solid or stranded, I want. Have to wait upwards of 2 months to get it. And who knows what the quality is, and of course it's cheap. I may order some just to see what I get, but I'm not going to wait 2 months to finish this project. Luckily, I finally remembered, that trashed debutante that I showed in my storage locker a while ago. The one that was missing just about every screw and so many bits and pieces that I just can't do anything with it. It has the wiring. I got to pop this apart to see what kind of condition it's in all the way to the other end, but from what I can see here, it's in pretty good shape. And this being a debutante, same 17-inch CRT and connections and everything, so it should just be a drop-in swap. This one has a good CRT too, as I do recall, without a burn in it, so I could transplant literally the whole thing. But I don't want to do that because I want to keep the CRT with the burned-in line, so I'm just going to transplant the yoke and such to it. Luckily, it's basically already been disassembled. The debutantes don't have arms like this. They just have caps that are on the end. Those are gone. There's just this masking tape holding the thing together. It's missing the spring down here. It's missing the plate up here. I think it was even missing the collar that this rests on top of on the chassis. That thing. So, in other words, I don't see any reason not to just dismantle this thing and use it for spare parts. All I can figure is that somebody was in the middle of restoring this set when something happened. Hopefully nothing really bad happened, like maybe they decided to get out of the hobby, or they needed some money, or they couldn't afford to pay their storage space fee. I don't know, but I'll certainly make some use out of it. So yeah, I think just be a one-to-one swap. I already loosened up the hardware on this, but it's still stuck on there. There's a plastic collar around this glass CRT neck that's stuck on there pretty good, probably from the heat. I'll work on that and do the same on this. So there's a screw here, and there's another one over down under here. Loosen those up and pull it off. I thought I was curious that the grounding wire on this one is just sitting by tension against it, which I think is the way it normally would be, but on this one they actually put it underneath the restraining or retaining loop. Now this is not quite the original CRT, so we can really notice a difference here. The Predictas were only made possible because they used a really, really short neck CRT. That was their big innovation. Also the Achilles heel of the 21-inch set because they went a little too far and the cathodes didn't last very long. But a 17-inch seemed to be pretty reliable. But notice the how much distance there is here, and notice this one's a good inch or so longer. But it still does fit within the enclosure, just barely. One feature I noticed on all these plastic back covers is some insulating pieces, only on one side though. They're attached to some plastic posts that were molded into the back, and then they melted them over to hold those pieces in place. So what's different about that side of the back? That's where the high voltage lead connects. So sit down like that. Now if it slipped off and hit that retaining system around the rim, that's grounded, so just short out the high voltage. What I'm thinking this is there for is in case that high voltage somehow made it past the grounding strap and touched the metal cap on the outside of the metal bar like that. So I think that's there to prevent any possibility of that high voltage making contact with that, which of course could shock somebody. Okay, here's what I decided. It was helped by my stumbling across this, which is a high voltage anode lead for one of these sets. I can't for sure say where it came from, but I've got one. It's been coiled up for quite a while, so it's a little stiff, but doesn't seem to be cracking as I straighten it out. I think a little bit of heat will help with that too. So that takes care of the high voltage wire, which leaves these two. Oh, hey Shadow, you coming to help? What do you think? I remembered I've got cables from a few tandem sets. Now, I still have two Predicta tandems that are not completely restored. I had three at one point. The one that's completely restored I sold. The other two have damaged head units. One of them, the cable got cut off right at the base. The other one, the connector on the end of it's bad. Well, I scavenged a couple other tandem cables from completely trashed head units where the CRTs got smashed and whatever. Basically, I just salvaged the cable. What I'm getting at is, in those wide, thick, 25-foot long cables are yoke wires and a high voltage wire. So I think I could sacrifice a couple feet of one of those cables and peel back the outer jacket and look at the inside wires. And thanks for the comment I got from one of my viewers who mentioned about scavenging wire out of multi-conductor cables. Because yes, that is a source. One other source I found potentially is from appliance wiring for like electric stoves that have sparks to ignite the gas element. Oh, did you find a wire that I could use maybe? Thank you. I don't think that's going to work, but thank you for trying. It's a little bit expensive, somewhat hard to find, but I think salvaging some cable is the way to go. So, what I'm getting at is I'm going to rewire this one. I'm just going to replace these three wires, I think. Assuming these are, we'll see about the rest. The rest I can use 600 volt PVC wire, which I've got plenty of. And this one I'm going to clean up because I want to test it out. So we will eventually, hopefully, be firing up both of these. On second thought, scrap that idea. Here's a tandem cable. The three in the center are the higher voltage conductors. The red one I believe is the high voltage, and the other two are the horizontal yoke windings. Those are shielded, and they're much thicker than I realized. All the other wires in there I do not believe are rated for high enough voltage. they're 600 volts or less. So the hunt continues. Alright, screw it, new course of action. Here's yet another head unit. This is the second set from that salvage video I did a while ago. Dead picture tube in this one. A pin broke off, broke the air seal. It's shot, lost its vacuum. Could it be rebuilt someday? Yeah, maybe. There hasn't been a functioning CRT operation in this country in almost 10 years, so I'm not going to hold my breath, but sure, I'll hang on to it. I'll put it in my storage unit. Meanwhile, I'll take this apart and I'll take the yoke out. I'll just transplant it to the other one. I do still intend to rebuild that yoke when such time arrives that I find suitable wire. Now this CRT may be dead, but this one is notable in that it is 100% original, unlike the other two. Still the original Philco low voltage CRT, and all the lead dressing is original. You can see that these masking tape to hold the leads down here. It's got some caution notes, one on the high voltage lead, so that's cool. I'll take some reference photos so I know exactly how everything should be arranged and aligned and so on. And then I'm going to transplant this onto this. And something else I scavenged from it. The Siesta set was missing the end caps. That's what goes onto here. I think these are solid brass, in which case I should be able to polish it up. I did pick up some steel ones a while back, but the same guy who makes these replica networks also now has pure brass end caps, so I could get some from him if I ever need some more. As far as getting this stuff off or out, you can shove the wires up and snake them through here, but also this does come off. There's 4 screws down below. And notice they were loose on this one. I've got another, actually this set I think. Yeah, I noted when I got it the CRT was tilted back a bit. I think it's because those screws are loose. So that'll be something to take a look at. I went out and I did pick up some basic supplies to try the brass solution with heat and a brass brush. I just got a small one. I bought the cheapest stuff I could get just to see how well this would work. I've already done some experimenting off camera and yeah, it works okay. With the stuff I've got, it would take forever, but I think I can demonstrate it. So here's one of the arms. Almost all the brass is gone from the cleaning and derusting process. So, basically, heat it up, just like in all the other videos on YouTube, and take a brush and go over it. For sure, having a vise and using a power tool of some sort with a brass accessory would make this go a whole lot better. The other thing I realize is that I'm going to have to go over this a bit before I can bother with this, because it's got a lot of really, really fine pitting and scarring on the surface, some of which gets smoothed out a bit by me going over with a brass brush, but there's still a lot of little tiny pits on it. Now, a couple things I'm curious about is, one is how durable is this going to be? What I typically do with things that I want to stay shiny brass, I get them polished up really well, clean it really well, and then coat it with lacquer. I have some specialty lacquer made just for going over brass, so it won't tarnish. Because I don't expect this will stand up too well to abrasive brass polishes. And since these bars get handled a lot, because that's how you swivel the screen, I want it to stand up. So what I'm hoping I can do is there we go. What I'm hoping I can do is get some kind of buffing wheel and get these really shiny steel, get all the little defects out. Use the brass brush technique. I've got some rotary attachments for a drill on the way to speed up this process, and then get it as nice looking as I can, and then clear coat it with lacquer. So, I mean, just in that brief time, it's almost looking as brassy as I need it to be. Here's one I was testing on earlier. They get hot, so you got to be careful where you set them down. What I'm curious now is I'm going to grab some metal polish and see if if I do a couple of swipes, will that just completely disappear or not. And by contrast, here's the other end. See if the lighting any better. So that's got some traces of brass left. In the middle on the elbow, it's kind of even more just silvery looking, and then this end has got the brass. Alright, let's see what polish does to it. I'm going to use a tiny bit of simichrome, metal polish, and soft cloth. A little goes a long way with this stuff. That was even probably too much. And that's kind of what I figured. It's getting dull already. It's not getting. It should be getting shinier. It's actually getting duller because I'm wearing away, getting down to the steel. So I'm hoping if I get the steel really shiny, the process of using a fine brass wire brush will leave a smooth enough, shiny enough surface. I won't really need to do any polishing after the words, and then I can clear coat it. Finally, the time has come to start putting this back together. Couldn't resist doing a little bit more cleaning on the chassis, and I did unmount the flyback. There's just one screw holding it in, and then two more down from below holding the the high voltage rectifier tube socket in place. Just a few wires going over to that. There are some metal tabs here and there coming up from the chassis. That's kind of an interesting way they constructed this. So all these like stakes that hold the board in and things that hold the cables down, they're all part of the chassis. It's kind of like a origami where they stamped it out and then folded it up and twisted it and such. Well, some of those I bent back, which allowed me to lift the wires up. I have the board reinstalled. The grounding stakes have been secured. I removed the audio output transformer to free up a little space around this terminal strip, and now I'm working on deciphering the wiring here and cleaning things up. Now there's a great parts placement diagram in this pocket service guide, and they label all the L lug connections on both boards, and they match up to the schematic. When it comes to the terminal strip, it's labeled B1 through B10, but they do not have a B1 through B10 on the schematic. I also looked at the full service info, and they give a really nice breakdown. They take this diagram there, and there's a chart above it showing, labeling all the L connections and showing what they go to, like B+, AGC bus, and so on. Wiper of vertical hold control, that kind of thing. But again, no mention of the B terminal strip or the B2 terminal strip, nor does the SAMs. So I'm lucky I've got a reference chassis, and it's not too hard to trace out the wiring, it just takes a little bit of time. I'll point out a few things to you guys. So I noticed there was one lug here that had a wire snaking around to the power transformer and nothing else going to it. That was the original low voltage tap for the CRT filament, the 2.68 volt tap. Remember, this set was modified for a different picture tube. So they moved that filament connection that goes up to this little tower connector to the 6.3 volt bus. There are a couple attachment points for that. I believe it's this wire. No, it's not that wire, but it's coming down through on one of these. Oh, this one. And this is notable because, so this red wire going to the power transformer goes to this lug, and the only thing coming off of it is a little red jumper wire to this lug. And then these wires go off to the filament on the IF board and two to this board. There are two filament connections, one here and another one. Why is there a little red wire? That's a fuse. A simple fuse to be sure, but they did fuse the filament. That's this. They used some number 26 wire. And there's that 2.68 volt tap, which is no longer being used. So if something was to short out this filament bus, that would burn out. So, for all the all the crap these sets take about their design, there are some actual decent design features. So they fuse the B plus and they fuse the filament supply. Most sets didn't back then. Let's see what else. I removed that power transistor, temporarily clipped one end so I can get down into this stuff better. I'm starting to pull off these lugs and deciphering them one by one because some of the wires went over to this filter cap that's no longer here, and I want to clean that up. And something else I noticed was that there's a green wire, plastic insulated wire going to the IF board. Goes over to here, and then there was a capacitor going from here to ground and nothing else. Yeah, that's really how it was wired up. Look on the schematic, that is this L6 0.1 200 volt cap going to ground, nothing else. I guess maybe in different models they use different value caps. They use this IF board in a lot of different sets. So maybe in some sets they use a different value for that cap. Or it just wouldn't fit on this board. Well, again, this is a case, it seems to me, of it makes sense to eliminate this wire, eliminate this terminal strip point, pull all this up, and put the cap in here now that they're so much smaller. That was a 0.1 microfarad cap. The original was like yay big. It would have taken up a considerable amount of space on this board. Modern one is minuscule, I'm sure, and that's a grounding stake right there. So how about we just put this cap right here? So that will free up yet again more wiring, and yes, can potentially confuse somebody down the road. Let's take a glance at that and see what is that used for. I think it's just a bypass cap for a bias point. There's 260 volt bus coming in, 220K to a 22K, and the junction of those two goes to that cap and up to this coil, which will then go around here and provide a DC bias to that grid. I think that's what it's for. It's just a bypass cap. So by all means, it will be more effective closer to where it's actually needed. So I'll continue on with that, replacing some of this wire with modern PVC wiring. Again, there's already some more modern wire in here, so I'm not worried about that. And I am making progress with the CRT head unit. I've transplanted the yoke from another set. I cleaned up some of the wiring. I'll be gradually putting this all back together to some extent. Like I said, I'm not going to put all the plastic back on and the trim and all that until we actually get this powered up and make sure it works. Something else I noticed on this chassis that's not on some of my others is this little assembly here. Well, I have a 2-page sheet of production run changes, and this is mentioned. It's one of the last ones. They took a signal off of the vertical output transformer secondary, goes to a resistor, cap going to ground, and then off to the CRT. I looked in the production run changes, and they called that a change to improve vertical shading. I think that's another way to say it's a vertical retrace suppression circuit. A lot of early TVs, especially TVs in the 40s and early 50s, did not have any type of vertical retrace suppression. So what am I talking about? Electron beam is going back and forth horizontally, and it's slowly going from the top to the bottom. When it gets to the bottom, it's got to get back to the top. While it's going from the bottom to the top, well, that takes a little bit of time, and the horizontal deflection is always going on. So, depending on how your brightness and contrast set and how the circuit's designed, you may see 5 or 6 zigzag lines as that beam is shooting back to the top. Early sets, I think they just didn't think it was an issue because the CRTs were very strong and fresh, and that beam coming back up is fainter than the normal scan lines. So I think you'd typically have your brightness and contrast sets so it wouldn't be visible at all. As sets age and you crank up the brightness and the contrast isn't as responsive, they definitely become more visible. And you'll see service notes later on, either from the manufacturer or tech notes like from service magazines, with tips on how to add it to sets. I'm pretty sure that's what this is. I think the 21-inch sets it's built into all the different models, but I thought the 70-inch sets all had it as well, but I don't think so. I think that's what this is for. So that raises the question of, say you've got an early production run set, should you add the production run changes? I think in some cases, yeah, especially for something like that, it's a definite improvement. Some of the others I noted were this resistor, the one that was burned up. They changed it from a 2-watt to a 3-watt during the run of this set. So I think they discovered even back then that this resistor needed to be a little bit beefier. This resistor, I believe, was increased in value, and a few other minor changes like that, like to improve fringe reception, decrease noise, that kind of thing. I figured I might as well document this while I'm tracing out the terminal strip wiring, so here it is. I'll do a neater job of writing this up and I'll post it online somewhere for future restorers. And while doing so, I realized this guy, 260 volt bus, that's the one up over in this area where I was trying to figure out where to put this filter cap. In hindsight, I could just as well have put it over here. This is ground, this 260 volt bus, put the cap right between these two. And this also feeds 2 other circuits. It goes to the IF board, it goes to the tuner. So putting it here is sort of equal distance between all the circuits. What I could also do is just add another one over here. These old caps were typically, the tolerance on them was plus 80%, minus 20%. So even as they were, said this was nominally 20 microfarad, could very well have been 35 microfarad. Generally speaking, going a bit higher with the capacitor is not an issue anyways. It's really just a matter of when you turn the set on, there's a surge current when the caps are discharged. But there's resistors between this cap and the power supply, so that would limit the surge current anyways. So I might very well do that. Just tack in another one here. That's one of the things that differentiate some high-end sets from lower-end sets. There's certainly earlier designs where I think they really wanted the sets to work well because the TV was a new thing. So you look at something like the first RCA TV, the RCA 630TS, the first post-war mass-produced commercial set, has a ton of filter caps. So does the early Dumonts. Later sets, more refined designs. Some of it was to save money, some of it they just didn't need it because of better designs, better circuit layout. But it certainly doesn't hurt to add an extra bypass filter cap here and there. So we'll see how this set performs. I can't imagine I'm really going to notice any ripple getting through to the IF, or a minuscule amount of noise getting through into these circuits up here, but just a thought. Rather than, it'll also be more obvious to future restorers, I think, if the cap went from here over to this location rather than being buried way back on the board over here. And if I should ever need to replace it, this would be a much more convenient spot. Likewise, the other cap that had been over here is going to be over here. So out of the 4 sections in this cap, 3 of them could very well sit on this terminal strip. Just a few more thoughts as I'm going through wiring this that I wanted to pass along before I get this thing completely done. One is the type of wire I'm using. I'm using 22 gauge solid. I presume it's PVC insulation. That's rated for 600 volts. Seems to be the same as what they used originally on all these wires. There's not a ton of current going through these, so that should be just fine. However, for the filament supply, that has a bit more current. You can see the wire coming off of the power transformer is pretty beefy. So for that, I think I'll use this 18 gauge stuff. You can see that's noticeably thicker. They also split this into 2 on the board, and I think that may have been to divvy up the current handling. So we've got one over at this spot, another one over here. If they just ran the filament to this post and then ran copper traces throughout it, I don't know how thick the copper is on this board, but if you want to run a lot of current, generally better to use a nice thick wire than rely on some thin traces on a circuit board. And this is also, I believe, rated for 600 volts. This is something called pushback wiring, which, if you've never seen this before, I'll talk about it more in a future video, but briefly, you don't need to strip it. This stuff is designed to, let's see if I can do this one hand, it pushes back. Then you can wrap it around a terminal, stick it on a lug, and solder it. You don't have to strip it back. This stuff, you do.